It's often very useful to write each of these voltages out in a symbolic equation, and also to draw something called voltage diagrams for each circuit element. Now I had you draw a diagram with respect to time when you were just kind of thinking about being a charge going around, but I want to give you a formal thing called a voltage diagram that you can rely on in analyzing circuits in the same way that you can rely on free body diagrams when you were analyzing old forces tasks. So here is what this would look like. So I can write down the loop rule by saying that the voltage across the battery plus the voltage across the light bulb is going to be equal to 0. And then, of course, if I wanted, I could solve that and say that, well, this means that the voltage across the bulb is going to need to be negative the voltage across the battery. And just like with anything else in physics, I want to try to understand what that negative sign actually means. So I've labeled some points on the circuit, A, B, C, and D. And then I've gone down here and I've drawn this voltage diagram for you at the bottom. And the way that I did this is I said I'm going to start at point A right here. I just decided I'm going to start at a potential of 0, at a voltage of 0, because I'm allowed to do that. I can put 0 wherever I want. And so I'm going to say I go along here, and then I go across the battery. And when I go across the battery, I have to switch colors. When I go across the battery, I get this increase in voltage. And I'm going to stylize that in my voltage diagram to just be a vertical arrow that indicates an increase in the voltage in the circuit as I move across the battery. Then between points B and C, I'm moving through an ideal wire. And I know that the voltage doesn't change through an ideal wire. Then I hit this light bulb. Light bulb's not an ideal wire. And so the voltage is going to go down as I move over that. How do I know how far it needs to go down? Well, the loop rule told me that I need to end exactly where I started. So by the time I get back to A, I had better be at the same voltage, same height on my voltage diagram. And the only way for that to be true is for the amount of voltage I gained from A to B to be equal to the amount of voltage that I lost from C to D.